Are you 12? This is the solutions to the 2020 Maths Extension 2 HSC paper. In this video, we're going to look at questions 11 through to 13. Question 11a. Consider the complex numbers w equals -1 plus 4i and z equals 2 minus I. Part 1, evaluate the modulus of w. So modulus of w, of course, is going to equal the square root of -1 all squared plus 4 squared, which is the square root of 17. And part 2, evaluate w multiplied by the conjugate of z. So that's -1 plus 4i multiplied by the conjugate of z is 2 plus I. And just expanding that, -2 minus I plus 8i minus 4 is equal to -6 plus 7i. 11b, use integration by parts to evaluate the integral between 1 and e of x ln x dx. Now, thinking about which to make u and which one to make v dashed, we can't integrate ln x, so it has to be u. And so v dashed will equal x. So u dashed is equal to 1 on x, and v is equal to x squared on 2. And so this is going to be equal to u times v, so ln x times x squared on 2, and our limits are 1 to e, take away integral between 1 and e of u dashed times v is equal to, substituting in, we get ln e times e squared on 2, take away, substituting that 1 in, I get ln 1, which is 0. Take away, let's tidy this up, we have got x on 2 dx. And ln e is 1, so e squared on 2, take away integral between 1 and e. Let's integrate, we've got x squared on 4, in between 1 and e, is equal to e squared on 2, take away e squared on 4, take away a quarter, which is equal to e squared on 2, take e squared on 4, is e squared on 4, and then we've got plus a quarter. 11c. The particle starts at the origin with velocity 1, and acceleration is given by this, and v is the velocity of the particle. Find an expression for x in terms of v. Okay, so we need to make a suitable substitution here. Now remember, our options are dv dt, which is no use to us because we don't want time, v dv dx, which I think is the one we're going to use, and d dx of a half v squared, which is no use because we can't integrate with respect to x. So we're going to use this one. So v dv dx is equal to v squared plus v. Dividing through by v, dv dx is equal to v plus 1. And switching upside down, dx dv is equal to 1 on v plus 1. So x will be equal to the integral of 1 on v plus 1 dv. Integrating, we get ln of v plus 1 plus c. At x equals 0, v equals 1, so 0 is equal to ln 2 plus c. c is equal to negative ln 2. Therefore, x is equal to ln v plus 1 minus ln 2, which is ln v plus 1 over 2. 11d. Consider the vectors u and v for what values of p are u minus v and u plus v perpendicular. So we want u minus v dot u plus v equal to 0. So let's expand that out. Now remember that u dot u is the same as the magnitude of u squared. And we've got the difference of two squares here, so we're going to do magnitude of u squared, take away, and then we've got v dot v, which is the magnitude of v squared, is equal to 0. Alright, so magnitude of u squared is going to be equal to -2 all squared plus -1 all squared plus 3 squared, which is equal to 4 plus 1 plus 9, which is 14. and magnitude of V squared is equal to P squared plus 1 squared plus 2 squared, which is P squared plus 5. So therefore, 14 take away P squared plus 5 has to equal 0. 14 equals P squared plus 5. P squared is equal to 9. P is equal to plus or minus 3. 11e. Solve z squared plus 3z plus 3 minus I equals 0, giving your answers in the form a plus bi, a and b are real. So we're just going to use our quadratic formula. So z will equal minus 3 plus or minus the square root of b squared minus 4 times a times c, all over 2a, equals negative 3 plus or minus square root of 9. We've got here minus 12 plus 4i all over 2 equals negative 3 plus or minus the square root of 9 take away 12 is negative 3 plus 4i all over 2. So we need the square roots of negative 3 plus 4i. We're going to let a plus bi, well, they use a and b, don't they? So let's use something different. Let's use x and y. Let's x plus iy all squared equal negative 3 plus 4i. Expanding out, x squared minus y squared plus 2xyi is equal to negative 3 plus 4i. Therefore, x squared minus y squared is equal to negative 3, and 2xy is equal to 4. Okay, making y the subject, we get 4 on 2x, which is equal to 2 on x. And substituting in here, we get x squared minus 4 on x squared is equal to negative 3. Times everything by x squared. And collecting together, we've got x to the power of 4 plus 3x squared minus 4 is equal to 0. Alright, up here, let's factorize. X squared, 4 and 1. We want the bigger one positive. Right, we'll get no solutions from that because remember x and y are real. So x is equal to plus or minus 1. Substituting in here, y is equal to plus or minus 2. So, therefore, the square roots of negative 3 plus 4i are going to be equal to plus or minus 1 plus 2i. And so z is equal to negative 3 plus or minus 1 plus 2i all over 2. Okay, let's separate these out. Negative 3 plus 1 plus 2i all over 2, and negative 3 minus 1 minus 2i all over 2, which is negative 2 plus 2i on 2, and negative 4 minus 2i on 2, and simplifying negative 1 plus I, and negative 2 minus I. 12a, a 50 kilogram box is initially at rest. The box is pulled along the ground with a force of 200 newtons at an angle 30 degrees to the horizontal. The box experiences a resistive force of 0.3 R newtons. R is the normal force. Acceleration is 10 meters per second. By resolving the forces vertically, show R equals 400. So we can see this force here of 50 G, and then this force here, but there's another one. There's this one here, the component, vertical component of the pulling force, which is going to be 200 sine 30. Now we know that the box is staying attached to the floor. It's not flying up into the air. So there is a net force here of R plus 200 sine 30 minus 50G, and that has to equal 0. So just solving this is pretty easy, isn't it? R plus 200 times a half minus G is 10 is equal to 0. R plus 100 minus 500 is equal to 0. R is equal to 400. Part 2 show that the net force horizontally is approximately 53.2 newtons. So again, we're going to have a component of this pulling force. It'll be 200 cos 30. And so the force, the net force, will be 200 cos 30 take away 0.3 r, which is 200 root 3 on 2 take away 0.3 times 400, which is 100 root 3 take away 120. And if we put that into the calculator, we get 53.2 newtons. Part 3, find the velocity of the box after the first 3 seconds. So we know that it starts at rest and then it is pulled along the ground. So F is equal to ma, and we know m is 50. And that's going to be equal to 53.2. So A is equal to 53.2 divided by 50, which is equal to 1.064. All right, we want time and velocity, so we're going to use dv dt is equal to 1.064. V is equal to the integral 1.064 dt, which is equal to 1.064 t plus c. Now at t is equal to 0, v is equal to 0, therefore c is equal to 0. So velocity is equal to 1.064 t. And we want after the first 3 seconds, so that's 1.064 times 3, which is equal to 3.19 meters per second. 12b. Particle is projected from the origin with initial velocity u at an angle theta to the horizontal. Particle lands at x equals r on the x-axis. The acceleration vector is given by this. Show that the position vector r is given by this. All right, so we're going to start with 0, negative g. And we're going to integrate it. So we're going to get a constant here, and then negative gt plus another constant. Now, initially, components of velocity are going to be u sine theta and u cos theta. So v of naught is u cos theta, u sine theta. So substituting that in, we're going to get C1 is equal to u cos theta. And when we substitute 0 in there, we're going to get C2 is equal to u sine theta. So V is going to be equal to u cos theta minus gt plus u sine theta. And now we're going to integrate again, and we'll get r this time will be equal to ut cos theta plus d1 minus gt squared on 2 plus ut sine theta plus d2. Now initially it starts at the origin, so r of naught is equal to 0, 0. So substituting in, we're going to get d1 is equal to 0 and d2 is equal to 0. Therefore, r is equal to ut cos theta and then ut sine theta minus a half gt squared. Part 2, show the Cartesian equation of the flight path is given by this. So we'll start with x is equal to ut cos theta and make t the subject. Now let's substitute it into y, which is u brackets x on u cos theta sine theta minus a half g x on u cos theta all squared, which is, this cancels, x tan theta minus g on 2 x squared on u squared. Now I can see how they want tans here, so I'm going to bring this cos squared up to the top, which gives us sec squared theta, because this will give us x tan theta minus gx squared on 2u squared tan squared theta plus 1. Which means I can bring out negative gx squared on 2u squared as a common factor. I don't quite have that here, do I? What have we got left over? We need an x on the denominator and a negative g, and we need 2u squared on the top and tan theta. I think that's right. And then I've got the negative out there already, so this is plus tan squared theta plus 1. Hopefully this turns out negative g x squared on 2u squared outside of tan squared theta minus 2u squared on gx tan theta, yep, plus 1. And that's it. Part 3, given u squared is greater than gr, prove there are two distinct values of theta for which the particle will land at x is equal to r. Now the coordinates here are x is equal to r and y is equal to 0. So we're going to substitute that in. 0 is equal to negative g r squared on 2u squared, tan squared theta minus 2u squared on gr times tan theta plus 1. In other words, tan squared theta minus 2u squared on gr tan theta plus 1 is equal to 0. Now, if there are going to be two distinct values of theta, then we want the discriminant to be greater than 0. And our discriminant is equal to b squared, so 2u squared on gr all squared minus 4 times a times c, which is equal to 4u to the power of 4 on g squared r squared minus 4, which is equal to 4u to the power of 4 minus 4g squared r squared on g squared r squared, which is, let's bring that 4 out, u to the power of 4 minus g squared r squared on g squared r squared. And that's the difference of two squares there. Does that help me? U squared minus gr and u squared, it does, gr on g squared r squared. Because, let me get a different colour. This is positive, and this is positive. This is the only thing that's in doubt. And we're told this, that u squared minus gr is greater than 0. So therefore this is greater than 0. There are two distinct values for theta. 13a, a particle is undergoing simple harmonic motion with period pi on 3. So period equals pi on 3. The central point of the motion of the particle is at x is equal to root 3. When t equals 0, the particle has its maximum displacement, which is 2 root 3 from the central point of motion. So the centre of motion is root 3, and at t equals 0, it's starting at the maximum point, 2 root 3 from root 3, so that's 3 root 3. And this is going to be the amplitude. Find an equation for the displacement x of the particle in terms of t. Now, we could use a is equal to negative n squared x minus c, but we're going to come into difficulty when we integrate that. We'll end up with v squared. And likewise, if we use this formula, we're going to have the same problem. So I'm inclined to just propose a model. Now we know it's starting at the maximum point, which means cos is most appropriate because it starts here. So I'm going to let x equal a cos nt plus c. And I don't need a phase shift in here because it's starting bang on that maximum point. So we know the amplitude is 2 root 3. Now n, period, is equal to 2 pi on n. So n is 6 and c is root 3. 13b, consider the two lines given. By equating components, find the point of intersection of the two lines. So we'll start with the x's first. So x is equal to 3 plus lambda 1, and x is also equal to 3 minus 2 lambda 2. So 3 plus lambda 1 is equal to 3 minus 2 lambda 2. So lambda 1 is equal to negative 2 lambda 2. Now let's look at the y's. We've got negative 1 plus 2 lambda 1 is equal to negative 6 plus lambda 2. So substituting in for lambda 1, we get negative 1 plus 2 lots of negative 2 lambda 2 is equal to negative 6 plus lambda 2. Okay, up here. gives us -1 minus 4 lambda 2 is equal to -6 plus lambda 2. Taking these over, we get -1 plus 6 is 5, is equal to 5 lambda 2, so lambda 2 is equal to 1. Now we only need to solve for one of these, either lambda 1 or lambda 2, because now substituting into here we can get the point of intersection, and it's going to be 3 take away 2, -6 plus 1, 2 plus 3, which is equal to 1, -5, 5. 13C Part 1. By considering the right angle triangle below or otherwise, prove this. Now you will be well schooled in how to prove this from x minus y all squared is greater than or equal to 0. And you can do it that way if you want to. We would just let x equal root a and y equal root b and turn it around, we will get this. But let's do it from the right angle triangle. We'll start with Pythagoras' theorem, so x squared will equal a plus b all squared minus a minus b all squared, which is a squared plus 2ab plus b squared minus a squared minus 2ab plus b squared. We can see these are all going to cancel out and we will be left with 4ab. And so x is going to be positive because it's a length of a triangle, the side of a triangle. It will be equal to 2 square root of ab. Now we know that the hypotenuse is always the longest side in the triangle, so a plus b is going to be greater than or equal to 2 root ab. Therefore, a plus b over 2 is greater than or equal to root ab. Part 2, prove that p squared plus 4q squared is greater than or equal to 4pq. So we've just got to figure out what to substitute for a and b. And I'm going to let a equal p squared and b equal 4q squared. Substituting in, we get p squared plus 4q squared over 2 is greater than or equal to the square root of p squared times 4q squared, which of course is equal to 2pq. Therefore, p squared plus 4q squared is greater than or equal to 4pq. 13d, show that for any integer n, e to the in theta plus e to the negative in theta is equal to 2 cos n theta. Okay, nice easy question. We're going to start with the left-hand side, of course, plus e to the negative in theta. And I'm going to change this. It's the same as cis n theta plus cis negative n theta, which of course is the same as cos n theta plus I sin n theta plus cos negative n theta plus I sin negative n theta equals cos n theta plus I sin n theta. Cos is an even function, so this is the same as cos n theta, and sine is an odd function, so this is the same as negative I sin n theta, and these two cancel out, and we're left with 2 cos n theta. Part 2, by expanding e to the I theta plus e to the negative I theta all to the power of 4, show this. Okay, let's expand. We've got e to the 4 I theta plus 4 lots of e to the 3 I theta times e to the negative I theta plus 6 lots of e to the 2 I theta e to the negative 2 I theta plus 4 lots of e to the I theta e to the negative 3 I theta plus e to the negative 4 I theta. Okay, let's tidy it up. E to the 4 I theta plus 4e to the 2 I theta plus 6 plus 4e to the negative 2 I theta plus e to the negative 4 I theta. Now we want to use this here. So on the left hand side, e to the I theta plus e to the negative I theta is 2 cos theta to the power of 4. And e to the 4 I theta plus e to the negative 4 I theta, so that is 2 cos 4 theta plus 4e to the 2 I theta plus 4e to the negative 2 I theta is 4 lots of 2 cos 2 theta plus 6. 2 to the power of 4 is 16, cos to the power of 4 theta is equal to 2 cos 4 theta plus 8 cos 2 theta plus 6. All right, where are we going with this? Let's divide by 16. So cos to the power of 4 theta is equal to 2 on 16 is 1 on 8. Cos to the power of cos 4 theta, plus a half cos 2 theta plus 6 over 16, which is 3/8. And bringing out a common factor of 1/8, we end up with what is required. Part 3, hence or otherwise find the integral between 0 and pi on 2 of cos to the power of 4 theta d theta. So obviously we're going to make this substitution. So integral between 0 and pi on 2 of cos to the power of 4 theta d theta is the same as 1/8 integral between 0 and pi on 2 of cos 4 theta plus 4 cos 2 theta plus 3 d theta is equal to 1/8. Now let's integrate. Integral of cos is sine. This is a reverse chain rule, so divide by 4 plus 4 sine 2 theta divided by 2 plus 3 theta in between 0 and pi on 2 equals 1/8 sine 4 pi on 2 is 2 pi, so that's 0. 2 sine 2 pi on 2 is pi, that's also 0, plus 3 pi on 2. Take away 0, 0, 0. That's 0, that's 0. We end up with 3 pi on 16. Okay, that's it. So in our last video, we'll cover questions 14 to 16.